The issue of heat dissipation from arc fault breakers, or AFCBs, has been a concern in the electrical industry. Studies and discussions have been ongoing to understand and address this potential problem. A 2010 study by Douglas Warshauer of Intuitic Testing Services found that AFCBs generate significantly more heat than standard circuit breakers. A 2018 study by Underwriters Laboratories, or UL, also confirmed that AFCBs can dissipate significant amounts of heat. The 2017 National Electrical Code, or NEC, recognized the potential for heat dissipation from AFCBs. It requires that AFCBs be spaced or mounted so as to not be affected by the heat of adjacent devices or wiring. The 2017 NEC does not require AFCBs in guest rooms of motels. However, the 2020 NEC is proposing to require AFCBs on all branch circuits that supply outlets and lighting in sleeping areas. Several strategies can be employed to mitigate heat dissipation from AFCBs. Firstly, spacing breakers. Leaving space between AFCBs in the panel allows for better airflow and heat dissipation. Secondly, using AFCB panels. These panels are specifically designed with larger gutters and cooling vents to dissipate heat. Thirdly, using separate AFCB enclosures. Mounting AFCBs in separate enclosures outside the main panel provides additional ventilation. Another consideration is ambient temperature. The temperature in the electrical panel should be considered when installing AFCBs. Choose panels rated for higher ambient temperatures or provide additional cooling. Additional considerations include fire safety. The heat generated by AFCBs should not exceed the temperature limits of the enclosure or adjacent components. Excessive heat can shorten the lifespan of AFCBs and other electrical components in the panel. The heat dissipation of AFCBs can contribute to panel heating and may reduce the maximum amperage rating of the panel. In conclusion, heat dissipation from AFCBs is a valid concern, especially with the increasing use of these devices. By addressing this issue through proper spacing, panel selection, and ambient temperature considerations, it is possible to minimize the risks and ensure the safety and reliability of electrical installations.